Okay, so happy live coding Sunday again, everybody. What I'm going to do today for our second cutting code cast here is I'm going to work through the Conways Game of Life kata. So I'm going to read out the webpage that I've got in front of me here just for a little bit of context. So the Game of Life is a cellular automation game devised by the mathematician John Horton Conway in 1970. So what this is it's a concept of a zero-player game where the machine plays itself, where, as we've got it here, evolution is determined by the initial state. So requiring no further input from a player, you interact with the Game of Life by creating an initial configuration and then watching it evolve over subsequent ticks, and certain patterns will begin to emerge. It's quite interesting. It's a fun little thing, and it's pretty famous. So what you'll find is if you drop this into a search, this is Conway's Game of Life running in the top corner up here. So Google have this as a little bit of an Easter egg. It's pretty cool. So we're going to build this, and we're going to build it TDD. It's a nice simple kata. So let's just close this. So the rules of the Game of Life are very, very simple. So the universe is an infinite, two-dimensional orthogonal grid of square cells, each of which is in one of two possible states, alive or dead. Every cell interacts with its 8 neighbours, which are the cells that are horizontally, vertically or diagonally adjacent. At each step in time, cells evaluate their state and transition between being alive and dead, depending on their neighbours. So what we're looking at here is a grid of cells and some game rules, and as the game steps forwards, the cells change state. So the initial pattern is the seed of the system, and then the first generation is created by applying the rules in the stories that we've defined below, simultaneously over every cell in the seed. So we're talking about 2 snapshots, so a current state and a next state. The rules continue to apply indefinitely, and you'll find that certain patterns appear and emerge from a successful running simulator. So it's kind of fun. So the stories that I've outlined here. So as a player, when I start the program, I see a game board on the screen. Very simple, first principles. As a player, when I start the program, I can generate a random initial state. So half or less of the cells set to alive at random, and living cells are visible on the rendered game board. So this is just a scenario that I've built so we can actually put some data in the system and render some stuff. Scenario 3, so this is actually the meat of the Game of Life. So, as a living cell, when the game ticks, I change state. So, if a cell has less than 2 living neighbours, when the game ticks, the cell dies. If a cell has greater than 3 living neighbours, the cell dies. If the cell has between 2 and 3 living neighbours, the cell lives. So those are the core rules of the Game of Life. And then we've got the 4th scenario. As a dead or empty cell, when the game ticks, I change state. So if a cell, an empty dead cell, has 3 living neighbours, the cell is born, it lives. So the examples in the Wikipedia page here don't load properly. It's quite annoying. But if I open up the Wikipedia page for Conway's Game of Life, there's loads and loads of samples. So you can see here we've got some running patterns here, some colourful stuff here, and the core rules of the Game of Life in a very, very wordy way. So these are the kind of patterns that we're going to expect to see as we build this up. It's all a lot of people have spent a lot of time categorising this stuff. It's kind of fun. But enough talk. Let's actually do something. So let's start at the beginning. So I'm gonna push these rules. Let's copy them. Let's copy these rules to Visual Studio, and we can start cutting some code. So, empty IDE, nothing here. Let's start. Let's drop the rules in here and see where we're going. So, standard Visual Studio layout. I'm using a couple of plugins. I know people asked last time about what I use, so I use nCrunch as a test runner. What nCrunch does when I turn this on is it just runs any unit test it finds on every key press. It's pretty cool. You'll see it initializing up at the side here. I'm going to be using ReSharper. You'll see it all the time. That's where all the unit testing snippets come from. But apart from that, we're just C#, .NET 4.5.1, I think, and nCrunch and NUnit. So scenario 1, as a player, when I start the program I see a game board on screen, so okay, great. I know the original rules of the Game of Life say that there's an infinite unbounded space, but what we're going to do, I think, is we're going to write the output of this out to the console, so we probably want to bound it. So let's write a test that says something like, let's call this game board creators. We're going to have some kind of class that creates a game board. Game board creator tests. And let's write our first test. So new board, given dimensions, is not null. Very, very simple. So obviously we don't have any code yet, we've just got this one test, so I'm going to say var board equals new Game of Life board, and we're probably going to give it some dimensions, so let's start with something obvious like 30 by 30 XY, and then we're going to assert that board is not null, and we're probably going to assert that board width is equal to 30. Let's Control D resharper. We're going to assert that board height is equal to 30. Very simple, very first principles. So obviously we're following the TDD red-green refactor, so my first red test is this one. And what I mean by that is it literally doesn't build, all the lights are red. So let's go somewhere, let's make this compile. So we're going to resharper, Alt-Enter our way to victory here. So yeah, int, so x width, int height, and no, we're still not compiling, so there's a couple of properties here. Let's create a read-only property width, yep, great, and let's make it integer, and let's move this up there, and we're going to do the same thing here. We're going to create a read-only property height, and it's also an integer, great. So now I've got compiling code, and you'll see from nCrunch's little red lights that it's blowing up at the not implemented exception in my constructor. Great. So let's, at the very least, make this first test pass. We've got a green test. So I can make a board that isn't null. Okay, obviously I see a game board on the screen. That's interesting, isn't it? Because what it really means is we need to render this board. So when you're test driving code, rendering and visual output stuff is really difficult, because obviously there are certain things that are more difficult to test than others, but I want to do this. I want to make sure I've got a test that can prove I'm rendering a board. So I'm going to need something like a test fixture for a game board renderer. Yeah, we'll do that. So I want a method called something like render given null game board throws exception. That's the first test, the test that drives out my API. Really nice and simple. So I'm going to say var game renderer equals new game board renderer, and it's a little bit meta. These are the tests. So I want to be able to create a game board renderer, and I'm going to then call renderer render null, and I'm going to actually assert throw. So this is a resharper snippet that I've thrown together. So I want an invalid, actually let's go with an argument exception, argument null exception, nice and easy. The expression I'm going for is that, and obviously this is my red test because it doesn't compile, and I want to assert that the message is game board cannot be null. Makes sense. So let's make some of these classes. Great, we've got a game board renderer. Now we've got a method that takes in a game board, Game of Life board, great, Game of Life board, and it does nothing. Actually, maybe what I want the API to this to look like, I'll deal with that in a minute actually. So this is nothing more than a null reference check, so let's use resharper to check the parameter for null. Throw no argument, null exception, and let's give it a meaningful message. So game board cannot be null. Stop. So now that test should go green. I wonder why that test isn't going green. I made a typo. Param name, string message. Let's see what it says. The strings differ. So it adds the parameter name. I always forget this. But we'll drop that in. No, I got a null check at the start. Great. So someone in chat is asking, is anyone here? Well, at the very least I am, and I can see the chat. So let's do the next thing, and I will hopefully answer if people ask me things in chat. Just bear in mind I might not notice at first. So I want another test now for the happy path. So I think the thing that you find as you're test driving out code is the first couple of tests really just help you explore your API and help you build out. So this is going to be render given valid not null game board, returns. I want to return a list of lines which I'm going to spit out in the console, because whilst I said that output and display is hard to test, that's quite an easy thing to verify and check using NUnit. So returns enumerable list, enumerable of lines to render. Great. So at this point let's just do a quick little refactor. So we're going to do setup, and we're just going to cut this line and bring it up here. And then we're going to use resharper to introduce a field. And if you're not familiar with the setup functionality in NUnit, it's just going to run this code before each one of these tests. It just helps us keep our tests nice and dry. So here I'm going to say render a render board, and let's say Game of Life board, new Game of Life board, 30 by 30. Great. And then what I'm expecting here, so we're going to render the cells as kind of an ASCII art thing, I reckon, just for this first pass. So if I give it a Game of Life board of 30 by 30, I expect 30 lines of text, and given a board where all the cells are dead, I would just expect them to be 30 lines of 30 spaces wide. So let's do that. So assert that the output.count. Of course I've not driven out my API yet, is equal to 30. In fact, let's just make this nice and easy. Let's do 5 by 5. It doesn't really make any difference for the purpose of the test, but at least it just shows that we can do this with small numbers and big numbers. So 5 by 5, and obviously this is the red in my test, in that resharper is telling me that the render a render method doesn't compile right now. So let's change this. Let's new reshuffle menus. No, I don't want that at all. Let's just change the constructor. So I'm going to return an IEnumerable of string. These strings are going to be my output line. In fact, just for the sake of ease, let's make it list of string. Stops us having to call to list or to array over here to actually verify our output. So obviously we're still not building here, the return is missing, so return new list of string. Let's cheat. Boom. Okay, great. So that's interesting. How about, so I can cheat here by, actually I want another test first. I want a test that looks very much like this. But instead of given a null game board, given game board with 0 dimensions returns, I just want I want nothing, I want an empty list. Let's just make sure I've got all my list semantics right. So, given a 0 by 0, I want nothing. I want an empty list, an array that has nothing in it. There we go, so that worked. Cool. And we're going to move on to here. So what's the simplest possible implementation that we can make this pass by? So I can cheat, but I know that once I cheat once, I'm just going to have to come and do the real implementation. So let's just make this nice and simple and say we've got a list, output lines, and then I'm going to say for each so it's kind of, I want cells, don't I? Now I need to think of the API on my Game of Life board because I don't really know what I'm iterating over. I think what I'm going to do is say for each var row in Game of Life board rows. Let's try that. So we're going for each row. So we're going to scan down, and each row will be a line in my array. I want to get the row length, and I want to return an empty, to make this pass I want to return an empty string that's the length of the row. So var output length equals row length. So working this way is quite unnatural if you've never really done it before, because we're kind of just fleshing out ideas of what this API is going to look like as we go along. We're not worrying too much about what any of this stuff really is yet. So I reckon my Game of Life board is going to have some rows, and a row is going to have a length, and that's going to be an integer. So let's actually just use the type here for the moment. So now I'm going to say enumerable repeat. Nice way to make strings. So I'm going to repeat a space for output length. This row, and then I'm going to say output line, add this row. And you're angry because an enumerable string, okay. So I should be able to call to string on that. I think that'll work. Let's cheat for the moment. Let's say 5. And let's just create property rows. Yep, fine. I'll work that out later. And this is failing because we expect 5 but there are no rows. Okay, so this isn't going anywhere. So row length. What is a Game of Life board? So let's make this an iList of string. No, what is it? It's cells. We've got rows is a collection of cells. It's a list of cells. No, it's a list of, ironically, a list of cells. It's basically a two-dimensional array. And we could potentially use a two-dimensional array to do this, but we'll work our way to it. So let's just do that. And a row now should have a length, because a row is a list. A row actually has a count. Great. So we're kind of looking right, I think. we just actually have to flesh some of this stuff out over here. So let's do enough to make the tests pass. So for int x, where width is the upper bound, we're going to say rows add new list of cells. Let's do that. And yes, I need to return the output line. So let's see what happens when this code runs. I have no idea what's going to happen, but we'll work it out. So it's blowing up. Why is it blowing up? Object reference not set to instance of an object. Very, very obvious. Made the rookie mistake of not initializing my list. Hey look, green, passing test. There we go. That worked. It's nice. So we've got the right number of lines. Awesome. I want to change this to returns correct number of lines. So given that, let's dupe that test. Returns lines of correct widths, because we're checking we have the right number of lines, not that the lines look correct. So given a 5x5 Game of Life board, that's the width and that's the height, so that should be how wide they are. So let's make it non-square to make this test a little more obvious. So I'm expecting, so that's interesting, isn't it? So I was expecting the height to be the number of rows, but that has just broken my test. That means I have a bug. Awesome. So given that I have a bug, let's have a look. So we're iterating over the rows. For each row in Game of Life board rows, and here I'm moving across, and that's because this should be y, not x. So this should be for every y in height I add a row. And we're green again. Great, so that was a bug. So now the output should be 5, but I'm expecting the first row is equal to 8, so I expect it to be 8 wide length. But there's no code that actually does this yet, so it's probably I expected 8, but it was 61 wide. Interesting. I have no idea why it's 61 anythings, but we'll work that out. So for each row in Game of Life rows, let's do some debugging. Let's break into the first failing test at this line. Let's hide my Solution Explorer. So first row is empty, count is empty. That's why this is definitely not correct. So this line very, very much isn't correct. So I thought enumerable.repeat generates a sequence that contains one repeated value. Okay, we're going to have to string join them. So enumerable.repeat was the correct thing there, so we've now got a sequence of spaces. We've got the correct amount of spaces, but what we want to do is we want to say string join separator of nothing. I'm sure there's probably a cleverer way to do this, but that should work. So I'm expected 8, but was 0. Great, because all my rows are empty. So as we iterate through the y's here, we're going to have to do something a little more interesting here. So for each, actually no, this is another for loop, this is a for to the x now. So for each x in the upper is width, so we're making lines and then we're going to make elements. So this row equals new list cell, So this row has a list of cells. I'm going to add this row at the end here, and then for each X, this row, add new cell. I think, yeah, green. Everything is now green. There are people in chat now. Hello, people in chat. So actually, we've got a renderer that works here. I mean, we don't have a game of life, we don't have anything really, but we've got a renderer. So now I can forget about rendering. So what I want to do is I want to write one nice covering test that, for the sake of illustration, let's, instead of using a space, I want to use a maybe a dot to signify a dead or empty cell in the game of life. So let's do another test, and let's say render given a dead cell expectation outputs dot. Let's do that. So we're just going to be really bad and copy that, and let's have a game of life game board that's 1 by 1, and we're going to render it, and I expect the first string here to be equal to dot, and that's going to fail because the code wasn't there to support that, because it's going to be a space. Great. The reason I'm putting a dot here is because we'll be able to see it in the console output. So if I do this there, great. My tests are green, which means I can now write a cheeky covering test. Render empty board of reasonable size looks okay to my eyes. So this isn't a unit test really, it's just a way to drive out some of this functionality. So I'm going to take exactly this test again, I'm going to dump it here, but instead of asserting anything, I'm just going to say for each line in output, debug.writeLine, line, and I'm going to do a game of life board that is 20 by 20, and then I'm going to run it. And for a change, let's run this in ReSharp as test runner, and we should see, there we go, a 20 by 20 game of life board. So I actually don't like the dots because it gives everything a funny shape. We could do something that's a little bit more fixed widthy or wider, so let's use a dash. So in order to do that, I'm going to change the test. Look, it failed. Then I'm going to come out here and change my empty, and it's going to pass again, and then we'll run it, and it should look a little bit more like a square. Well, maybe not. We'll go with it. We'll go with it. Great, so we've got a game of life renderer. So I know that works. I'm going to get rid of it. Let's move it to another file. So that was Alt Enter, just shipping it over there. We've got a game of life board. The board initializes itself with a height and a width. You can iterate over the rows, that's great. Let's move that out here. In fact, I want to write a test that covers those rows because I'm feeling a little bit uncovered there. Game of life renderer tests, let's get rid of these, so let's move those to game board renderer tests. Go jump back over into class 1 over here, new game board. So this is back where we started, great. So a game of life game board has its width and height set correctly, but most importantly, new board, actually let's get this right, constructor, given dimensions, rows are not null. Let's change this to CTOR for consistency. So pretty much the same test, but what we're asserting on here is that board rows is not null, and we're going to assert that board rows count is equal to 30. And for the sake of argument, we're going to say board rows 0, 0. The first line is equal to 30. Did I get that right? No, I don't think I did. Let's see what that says. Oh, it's a Game of Life cell. It's not equal to 30. That's the cell itself. So the first row's count is equal to 30. Brilliant. And I also want to make sure that it has populated this whole board with cells. So CTOR given dimensions, cells populated. So bar board equals new Game of Life board. Let's just do one by one. Let's make it really easy. Assert that board rows 0, 0 is type of cell, and that should be green. Great. So what I've proven here is that I can generate a board with valid widths and heights, and that cells are generated. So if we jump back here, scenario 1, as a player, when I start the program, I see a game board on the screen. Done. Boom. Nailed it. Let's get rid of that. Finished. So we've obviously not built the Game of Life yet, but we're getting there. So as a player, when I start the program, I can generate a random initial state. Half or less of the cells set to alive at random. And this was something I blatantly made up, wasn't it? Living cells visible on the rendered game board. Okay, cool. So pretty easy acceptance criteria. So generate a random initial state. So at the moment, we're just generating a fixed state. So first, let's do a little bit of refactoring here because this is ugly. So let's extract this to a method. So that was control RM. Right, state. There we go. Not sure why it needs to pass the width in there. Let's take that out. I think reshuffle. That's why reshuffle was only doing what it was told. And I perpetually hate this. So let's just call that row. And let's verify all the things to make them consistent. So now we've got some rows, we've got some cells, but the random initial state here is the interesting piece. So how do we want to test this? So I suppose we need some kind of random number generator. What were my acceptance criteria? That half or less of the cells are set to alive at random. So okay, fine. That's cool. I think half or less was nothing more than me just making up a random acceptance criteria. So let's take that out of there. We want to pull this out into a method. So let's go with generate initial state. Var cell equals generate initial state. Let's do that. So I now have this method that returns a cell. Half or less. Okay, so maybe I want this initial state thing to be a class of its own. It doesn't really feel like it has to be in the game board. So let's just pull this out into a new class. So public static class cell generator. Why not? Public list generate cell. Cell generate cells. Int number of cells to generate. So I guess what I'm thinking here, let's just throw in not imp. What I'm thinking here is we'll make a class that, why are you angry? Can I have a non-static, oh. There. We're going to have the static helper that will generate a bag of cells with some of them being dead and some of them being alive, and then we'll just iterate through here allocating them. And let's not make it a static class because statics are evil. We're going to have a cell generator, and what this is going to do for the sake of argument, I think we're going to put it in here. Cell generator. So this is basically an incredibly simple example of a strategy. It's the strategy pattern. We're going to pass in a thing that will generate the dependencies. We'll pull that out here, and we're going to say generator generate cells. Actually, what I want to do is stop coding and write some tests for this. So let's just leave that there for now. Let's make the cell generator. So let's jump back over here and write some tests for this cell generator of ours. Also, let's move cell to its own class. Great, so we've got some stuff over here. It's time to write some tests. So, test fixture. How I'm doing per time, 40 minutes. Okay. Class cell generator tests, and the scenario is half or less of the cells are set to alive at random. Okay, fine, I can write a test for that. Test generate cells given 2. Ask for 2 cells, 1 alive, 1 dead. First principles. What will the cell class do? So the cell class will be the little bag of state explaining whether it's alive or dead. You know, to be honest, maybe nothing. It might actually just be an enum, just some kind of state. I'm not really thinking about the cell class yet, but we'll see when we get there. My gut says probably nothing, so it's probably not really a type at all. So, generate cells, asks for 2 cells. Okay, so our generator equals new cell generator. Great. Generator generate cells 2. Cells assert that cells, so I can't guarantee order because this is random, where X is alive. Let's go with that. Let's see, count X is alive is equal to 1, and X is not alive equal to 1. So that's the simplest possible test that I can write at the moment for this. And there we go. That's one of the things the cell class will do. It'll have that. And for some reason this test isn't running. Public class test fixture test. I think I'm not building here. Game of Life board doesn't take a constructor with 2 arguments. You're right, it doesn't. So let's, for the sake of argument, make this an optional parameter, and we can say generator is generator or new cell generator. There we go. Simple API design. We might want to override the cell generator, but we're probably not going to want to all the time. Let's not messy up our code in it. And actually, while we're here, I want to refactor and extract an interface. Great, because I'm probably going to need that. So let's call this I generate a set I cell generation strategy. And no, let's not do that. Great. So let's just drop that in there. It's a cell generation strategy with a default implementation of the cell generator. So all those tests now pass. Obviously this one doesn't. So let's generate some cells. Okay, so simplest possible implementation, less than half. Okay, great, less than half. Is that what my acceptance criteria said? Half or less, so 50% are alive. So what I'm going to do is I'm going to say var alive cells equals number of cells to generate divided by 2. Let's return, so var list equals new list of cells. No, not that. Silly resharper. Silly David, actually. And then let's see if I can use enumerable repeat again. I like enumerable repeat. Enumerable repeat. I think I can just do new cell is alive true alive cells, list add range there, and let's go for half. Enumerable repeat is alive false. Well, actually, don't even need to specify that because false is default. And boom, my tests pass. So that's good. What are the edge cases? The obvious edge cases is that that'll only work if it's an even number. So let's write a test for exactly that. So given, ask for 3, less than half, well I don't want more than half, so 1 dead, 2 alive, returned. So this will be my edge case. So generate cells 3, is alive is equal to 1, is not alive is equal to 2. It's interesting. So how many cells did I actually get? I only got 2 cells. Great. Cheapest possible implementation, while list count does not equal the number of cells to generate. Let's just fill it up with dead cells. List add new cell. There we go. Green. Awesome. I'm sure this is horrible code and we could do it better, but we can refactor this later, I'm not worried about it. So I've got a game board renderer. That works. Let's inline that actually, I don't like that. And let's see if this looks better as link. Game of Life board, row select, join. No, I don't like that for now. Maybe we'll refactor it to that later, but we'll take a look. So let's jump back here. So when I start the program I can generate an initial random state. Half or less of the cells are set to alive at random, so I think that'll work. Living cells are visible on the game board. Okay, let's write an example test for this. Just a little covering one. Test, public void ctor, new, given dimensions, I totally see the right thing. Nice and simple, nice and easy. So let's say var board equals new game of life board. Let's just make it a 20 by 20 or a 10 by 10 actually. Let's make this easy. And then I want a var renderer equals new game of life. What do I call it? Renderer. Game board renderer. And then we say output equals renderer render board. And then for each var line in output, I'm going to say debug.writeLine line. So I think we're going to get a fairly random board with less than half of the things in there because my tests will say that that'll work. And that's the whole point. So let's run this using NUnit because it will give us slightly nicer output. And it didn't. So why didn't that work, and what's the test that I can write that fails? So it's blatantly because I'm not paying attention to the state of alive or dead when we're writing out. So I have tests over this for the renderer. So let's just move these cell generator tests out of here. And I want to go to my game board renderer tests. So I have a test that proves, given a dead cell, I get a dash. Let's write one for an alive cell. So given a live cell, outputs dash. And let's say an alive cell outputs a hash. So alive cells are going to look like a hash. So given a game of life board, and this is exactly where I want to say I want a mock cell generation strategy. So let's just stick mock in here. And it's MOQ. There we go. Let's drop this mocking library in. Great. And I'm going to say var mock cell generator equals new mock I cell generation strategy. Bingo. And I hate having mocks in tests themselves, so let's just drop that into the setup up here. Mock cell generator. You should always try and keep all these declarations away from your test code. So what you'll notice here is my tests are very, very, very small, with only the things that I'm interested in seeing actually written in the test themselves. So all I'm going to do is I'm going to stick that mock cell generator in here, and beforehand I'm going to set it up. So mock cell generator setup, generate cells, it is any int, I don't care how many, and I want it to return alive. So a new cell, oh god, of course, so it wants to return a list, so all my cells equals new list cell. New cell is alive equals true. So I'm basically hard coding the cells that are going to come back when the grid generates. And actually one of the things I like doing here is I like picking up all this kind of setup. I like moving this up here. So I've got a mock cell generator, and I've got a list of cells. Oh, typo. So these cells are always going to come back. I'm just going to make a list. So the reason I do this is I like to keep all the mocking really, really away from the tests. It makes them much more elegant and readable. So what I've done here is by default, I have set up the mock so that whenever the mock is injected and it generates cells, it returns the contents of this list of cells. What that means is in my test down here that's failing, I can just say cells add new cell is alive equals true. That's it. And the mock will have already been wired up, and it works because the list up here was already declared, so the reference to this list is already configured with the mock. All I'm doing is manipulating the contents of that list. It's a good way to dry out your tests a little bit. So obviously this test is failing because there is no rendering logic. So let's go into here, because all my renderer is doing right now is repeating dash. Okay, fine. So that sucks. So let's say for each var cell in row, probably want a string row, no, row text, let's do that. And now I should use a string builder, so let's do that before someone shouts at me. Buffer equals new string builder. For each cell, let's do the simplest thing and then we'll clean it up. Append, we're going to append a dash, and then we're going to delete that, and we're going to do buffer to string. So now I should just have one failing test. Yep, still the same failing test. And all I'm going to do now is say if cell is alive, buffer append hash, else. there. And then we can even just do that. So there's my rendering logic, and still broken. Interesting. Wasn't expecting that. So let's debug through and see what I got wrong. So I've got a board, I've got a generator, I've got a width and a height. I didn't plug in my generator. That's why. So how do I write a failing test for this? So this is part of the constructor test. So if I'm going to go back up to my game board, not my game board renderer, it's my confusingly named class 1. I should probably rename this file. And actually, this should be called Game of Life Board Tests. Simple as that. And what I actually want is I want a test here that says CTOR given dimensions generate cells using supplied strategy. Given dimensions and strategy generates cells using supplied strategy. So what I've done is I've hooked up this generator, I've put it in but I've not used it, and unless I can write a failing test I shouldn't be able to fix the bug, but I reckon I can. So I'm going to make a board, I'm going to say new Game of Life board, and like all these kinds of examples you should start from first principles, so let's just do a 1 by 1, nice and easy, 1 by 1, and I'm going to give it a mock. So because I'm only using it in one test, I believe, yeah, I don't have any mocks in here, I'm just going to declare it here, mock strategy equals new mock I cell generation strategy. Great. So I'm going to put mock strategy object in here. I'm going to say mock strategy setup x generate cells. It is any int. Syntax is a bit long-winded here, but mock's pretty good. Returns new list cell, new cell, and what I actually want to do is make sure it's assigning this particular cell. So this is a bit of a cheap hack, but let's go with it. I want to say ID. I'm just going to give the cells a random ID equals GUID, new GUID. So just let me check that the cells that are getting generated are the cells that are coming back from the strategy. That's great. The cells have a random ID, expected cell, and that is a mouthful of a line of code, but expected cell equals new cell. Great, so I've got a cell which will have a GUID associated with it. I've set up a mock that says when I generate cells I return a list with this one exact cell in it, and now I'm asking the Game of Life board for 1 by 1. So now I should be able to say assert that, I didn't even need that GUID, I'm being stupid, I'll take it out, assert that board rows 0 0 is equal to expected cell. So rows first line first cell is equal to expected cell. Let's delete that GUID because it's junk, don't need it. So I'm going to close this again, and it's obviously complaining, and the reason it's complaining is that we're not actually using the output here because we've just got a hard-coded return new cell. So generate initial state, let's kill that static. I want to say generate cells, bag of cells, sounds like a bad joke, generator, generate cells. I want to get enough cells for everything, so width times height. Great, and then generate initial state, so this is going to give me, right, so first let's inline this. Actually I want a bag of cells at the start here, bag of cells, and actually what I probably want here is a new stack of cell seeded from, can I do this? Will you work? Yes, you will. So that'll give me a stack of cells, and I can just say bag of cells pop. So that will remove and add the first cell from the collection. And everything's green. Awesome. And it's green because the expected cell got assigned correctly. So if I now, let's remove that. If I run my totally see the right thing covering test here, I am hoping I'm going to see something useful. Interesting. So what we're seeing here is, because I'm not doing any kind of randomization, I'm just generating exactly half or less alive cells, they're kind of filling up in order, which isn't a great way to randomly generate the game of life. So what we're going to do is we're going to write a test that covers this randomization. So I need to go back to my cell generator tests. So these are all good. What I really need to do is generate a, this is an interesting test because it's going to be flaky. So generate cells, ask for 10 cells, unordered, twice, order shouldn't match. Now, because of the random nature of random, I'm not sure if I can write this test, but we'll give it a go. So var generator, new cell generator, and actually again this is the time where I want a setup, because I keep on doing that. Pick up this generator and put it up here. Boom, boom. Because again, I want to keep all the stuff out of my tests that I don't care about. So now I want to say cells equals generator, generate cells 10. Our cells equals generator, generate cells 10. And we're going to say cells 1, cells 2. So the problem here is, theoretically I could get the same assortment of cells repeatedly. Assert that cells 1 is not, interesting, returns a constraint that tests whether a collection is ordered. I've never seen that before, but that will fail because it's a list. Interesting. You know what, I'm going to Google this. C# force a collection to be unordered. There must be something interesting in here. And you can sort it by a random number, can't you? Tell you what, let's say, for, this is a really dodgy test, but for each in cell 1, for each cell in cell 1, actually let's convert this to a 4 in the magical resharper. Assert, I'm actually not sure how to write this. I want to say that the problem, see, I'll vocalise the problem. The problem is that cells could be in the same position, but hopefully would not be. Let's come back to this. I'm going to make this person, I'm just going to do an assert fail here, because I don't want to get myself into a false sense of security. Luckily, I believe I can just do order by GUID, new GUID, and it should to list. That should shuffle my cells. Actually, that's making everything go red. I don't like it, I'll lose things. So, this test needs to pass before we finish. I need to work out how to write that assertion. So now, I reckon if I run my Game of Life board tests, I think this will look relatively random. And there we go, I've got an initial state for the Game of Life. Awesome. Nice, easy. So let's go back to my stories. So, as a player, when I start the program, I can generate a random initial state. Boom, done. Half or less of the cells set to alive at random. Yep. Living cells visible on the rendered game board. Yep. So here is the actual Game of Life. So as a living cell, when the game ticks, I change state. If the cell, so there's some rules here. Okay, cool. So these are the rules. So I think I need something like tick. Context is so tick executes all rules. Tick given a board executes rules across, I can't spell today, all cells. Let's try that. So we have this concept of a rule, and we have cells, and the rules are going to apply to the cells. So given a board with a 1x1, given a board with a 1x1, I want to say board tick. Maybe board step. I like step better. Maybe increase generation. Let's just go with step to start with. And then I want to assert the state. So, of course it's up there. So let's move these things into their own classes, their own files even. Move. Yep, great, so they're in their own files. So we've got this method called step. So what would I expect? So I would expect all the rules that I'm provided here. So we've got a cell generator. So I'm thinking, and this is the bit where TDD actually helps you with your design, I'm thinking that I want to pass it some kind of interface. I am a game rule. So we've got a game rule, and I want to apply each of the game rules to the board. If a cell has two living neighbours. So it's like my rule applies to each cell. A cell gets picked up, the states get assessed, and it creates a second board and then switches. But actually, let's not get too pent up on this. Let's actually test the rules themselves. So, step given one living cell on a 1x1 board, the cell will always have less than two living neighbours, dies. That will always happen. So what I'm going to do here is actually make a new constructor here, a cell generation strategy. So I think I'm going to make a new cell generation strategy, which is static list strategy. So I'm going to do this. Number of cells to generate. But actually what this is going to do is it's going to take a constructor with an IEnumerable cells, and all it's going to do is return cells. So this is just a nice quick way of me putting in stubs. It's kind of a test double. I probably would not write a test for it itself, because I'm going to go back here and I'm going to pass it a new static list strategy. Cells. So var cells equals new list, and all that really is doing exactly the same thing that mock was doing, but it's a little bit syntactically shorter. I want a list of cell, and I want a new cell that is alive is true. And actually, let's do that. Great. So new 1x1 game board with a static list strategy with a cell that is alive, and when the board steps, it's getting a not implemented because we've not implemented the step. I want to assert that board rows 0, 0 is alive is false. So it went in alive, it should now die. Let's make that work. So step. So I'm about to see a pattern here because it looks like I'm going to be iterating over this again. This exactly same shape. So I'm going to copy it for now. Actually no, I'm not. So for each our cell in row, we need to kind of build up a secondary state, really, don't we? It's almost like we're going to remove all of this afterwards. So there's a previous state and then an eventual state. So I'm going to make another one of this, one of these. Target state is a new list of cells. For each cell in row, it's for each row in rows actually. So as I'm moving down through the rows, target row equals new list cell. Very, very similar to this. It's literally just the same. Just the bit that I'm doing in the middle is different. And because I've copy and pasted that, that means something has to change here. But we'll come back to that in the refactor. So that's not what I'm doing here. So rows, I don't want to set rows, I want var target row, target state, and we want to execute the rule here, basically. So our new state equals get work out if cell is alive, determine cell state. Let's just do that. We'll make a method for that. And that's going to bring back a cell. So interestingly, we're probably going to need to know what the coordinates of the cells are to do this. And this is really hacky code, I don't like it, but I'm sure we'll do something better. So what I want to do, actually, when I'm generating the cells, I want the cells to know where they are. I think that's probably important. So I'm going to write a test for that first. So when this happens, when the cells get assigned, generate cell using supply strategy, I also want to assert that board rows 0, 0, x is equal to 0 and y is equal to 0. So I want to assign the positions. I feel like they're going to be useful. And obviously those are the defaults. That test is never going to work. It's never going to prove anything unless I go into the cells, and by default x equals int 32 min value. Let's just make my tests deliberately fail. It's the right thing to do. So this now should fail. I think I'm not building. Oh no. Is that really working? I'm really surprised. Really surprised that that's working. I'm so surprised that I think I'm going to step through it. Game of Life board tests here. So this is returning a new cell. The new cell initializes at min value. Let's debug through this because I think this should fail. Expected cell. There we go. X and Y is very low. We're going to do this. We've got a generator, width and height, generate state. So we've now got a bag of cells, which is a cell with X and Y being crazy low values. So the row now has a cell, X and Y are definitely so is the expected cell. There we go. I think nCrunch got a bit confused by that, that's all. But I'm glad it failed. So the reason nCrunch got confused is I've got it only running the tests it thinks are impacted, so it's trying to work that out ahead of time. Okay, so let's make this test pass. It's really simple. I'm just going to make sure that new cell, oh, that wouldn't make it pass. Cell equals bag of cells, pop, and put cell in there. Cell x equals x, cell y equals y. So my cells now all know where they are, which is useful. Yep, down to one failing test, which is just this. So I'm going to jump back into my step. So I need to determine the cell state. So what's the simplest thing? Ifs, let's pass the cell to start off with. Determine state for each x. So we're just making a new thing here. Actually, this is the wrong loop completely. Wrong loop completely. So for each bar row in rows, for each bar cell in row, do that. Determine cell state cell, bar new cell state. Do that. And I'm just going to say if cell is alive, return new cell state dead. X equals cell x, y equals cell y. Else true. So if it's alive, it becomes dead, otherwise it becomes alive. So I would have thought that might have cheated this test into passing. But apparently the cell is alive. That's because the board hasn't been updated at all. So I've got a new cell state, but I'm not doing anything with it. Just make that static, it doesn't matter at the moment. Actually, that's not. Okay, great, so for each cell in row, what I actually want to do is kind of clone the list to start with. So, generate state. Interesting. So I kind of want to make an empty list. Okay, so target state is that for each cell in rows, for each cell. Okay, so target state, so our row equals new list of cell. So new row, and then target state rows, add new row, and I'm saying here new row, add new cell state. So I'm basically iterating over the existing bag of state, determining a new cell state, and then building up a new one. I then want to say rows equals target state. And this is so not multi-threadable code right here. I probably need some locks or something. Probably use a concurrent dictionary. Okay, cool. So I can now step, and I've hacked my test into passing. So let's go back to here. Given one living cell, it dies. If a cell has less than 2 living neighbours, cell dies. Okay. If it has more than 3 living neighbours, it also dies through to overpopulation. So the difficulty in rendering this for a test here. Okay, so we're going to assign the cells in order here. So given 2 living neighbours, so let's make a test that makes this work. So given 3 greater than 3, so 4 living neighbours. It's interesting because I've done this in a different way before. I didn't approach it in this way, but I don't know whether this is better or worse. So we're going to have a board which is 2 by 2, and the first one's going to be alive, and then we're going to have, let's overpopulate it, so true, 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 true. So we've got 4 living cells, which means that the first one has 3 living neighbours. The second one, okay, so let's make it a 3 by 3. 3 by 3, so we need 6 cells. Let's do that up. So first row, second row, third row. Now, I think if these are all alive, this one should die. I think that one should die, that's what my gut says, because its left and right are alive and it's bordered completely. So I want to check, that's 0, 1, so I think it'll be 1, 1. That should definitely die. My test is already passing. Okay, that's annoying. What's a simpler case? If a cell has less than 2 living neighbours, the cell dies. less than 2. If it has, let's do 2 to 3, the cell lives. Let's do the living case, because I think at the moment everything always dies. Everything dies. Wonderfully bleak. So let's dupe that up. Given 2 living neighbours, lives. Yay, happy cell. So that should live. They should. So I would expect 0. So that's the X. That's the Y. So the row is on the horizontal. I expect the middle one. That is one row. I expect the middle one to be alive. Wrong way around. Working with offsets, and this is a pain. Really interesting. Rows first. So only one. Oh, I understand. It's a 1x1 board. Being stupid. So this is a width is 3. So then rows 1, row 0, element 1 should be alive, and hopefully that's not an index out of range. Great. Great. So given 2 living neighbours, lives, should stay alive. Actually, these should die because they're on the border. It's kind of interesting. Should die, should stay alive, should die, because it has 2 living neighbours and it's snapshot state. So let's make that work. This is getting a bit hairy, I don't like it. I don't like this code at all, it's just a bit nasty. Okay, so determine cell state. We get given a cell. Naturally we need the board, don't we? We need the board. So determine state. I feel like this should be a data structure in and of itself. Actually, I wonder if this is the right time to convert it to some kind of 2-dimensional array. Everything except this test is green, so now I've got one fail. Let's do it. So rows, let's try it. Public rows, oh god. I want a cell array rows. Still enumerable. And then I think this is just here is a new cell width height. And we're not really using this at all because it's not adding anything. We're just saying rows x, y equals cell. Are we building? No, we're definitely not building. What's angry with me? Row is not enumerable. Interesting. What is row? Of course. Of course. So the way you iterate over 2-dimensional arrays is a bit stupid in C#, and it's really a bit rubbish. So the syntax is breaking here. So I believe we need to say in rows get, you need to do a for loop really. So for Upper should be rows get length 0, I think, the first dimension, and that is the Y. This is our Y here, and then we're saying for each in rows get length 1 probably. Oop. For each cell in 4 in rows get length 1, and this is the X. So this is this bit here. So I also need to pull out the cell. So cell is rows XY, I believe. See if I remember that. I'm not worried about new row at the moment, I don't think. Actually, maybe I am. So I think that is equivalent, I believe. So they updated but never used. So target stay add new row. Feels like this code is now wrong, but yeah, because what we actually want to do is keep this consistent. The target state should be new cell width. That comes out, and it really is the same code. So target state xy equals new cell state. Are we even building? So close. Yes. So this is a bit naff, I think, now. So I'm going to change this to be board. So that's going to be board, but I actually want to say public IEnumerable list cell rows. I want to say for each var, I want to basically take the guts of this. Let's fix my syntax. For each var y, so this is looping through the y's. So var row equals new list cell just means that I still have the syntactic sugar for my tests. And then we want to basically do this as well. So this is my loop. So I want to say var row here. I want to say row add. It's not row really. Board XY, and then here I want to yield return rows, row. So I think that means that my tests will broadly still compile. So board 0, of course, so rows. So these tests here, and actually I'm going to make it a list for consistency. Yield return new list of cells. So this is a list of all the rows. I'm going through the rows, I'm constructing a row, I'm returning a row, because a single row is an IEnumerable of a list of cells, which means my tests probably will change a little bit, but I will work it out. So I think I can use count as a method here instead, as an extension. Because, yeah, I can't return a list here with a yield. That's fine. But what I can do is I can use link and use first and things like that. So let's refactor these tests so they work again. Rows 0, so rows first dot count. Rows first. Yeah, this will work. This will work. And similar here, first. And I wonder if I can use this rows property inside the class itself rather than repeatedly doing that loop, because that loop is really nasty and I don't like it. And another one. And one last one. Rows. So this isn't first, this is skip one first. Let's see if I build. So this is my renderer. So for each row in the board, and this is a cell. Rows. Let's see if all but one of those tests continue to pass. Brilliant. That's good. So we're back to kind of where we were. I'm just going to really kick nCrunch and make sure it runs everything here. I've still only got one fail, which is the story I was working on. So that's good. It means I can come back into my Game of Life board and I can get rid of that. And I can use this structure here elsewhere. So instead of having to do this by hand here to generate, no, this is generated, so this is building it up. So I'm going to need to do it by hand when I'm building it, but whenever I enumerate over it, like in step, I should really say for each var row in rows. So if I do that, at least I'm not duplicating this logic because it's really horrible. And then for each var cell in row, oh god no, in row. Yeah, perfect. And then this comes out here, this goes in the middle. So we've already got the cells know their XY. Great, I knew there was a reason I put those in there. This comes out, and at least that's a little bit less sucky. So this is the hook for the rules, basically. This is the hook for the rules. And I've got a Game of Life board that steps. So what I really need to do is, given a single cell, I need to get all its neighbours so I can evaluate things. So determine cell state. Let's go back to my tests. Given a 3x3, and we have indexes and offsets. These tests feel too big, actually. These tests feel way too big. I don't like the amount of setup required. Less than 2 living neighbours, a cell dies. Given 1 living cell, it dies because there's no neighbours. Given 2 living neighbours, it lives, but it isn't. Rows first. Cool. So that should stay alive. So I'm going to get up my scenarios over here. I'm going to stick them on my other monitor so I can read them all the time. Okay, so given a cell at x, y, I think I also need the board here, but let's see. So var get neighbours. Let's get neighbours of cell. And that'll bring back a list of other cells from a cell. Okay, so for neighbours, I really can't spell neighbours, list cell. I'm going to say I need to get the x and y, so if cell, right, so the neighbours are in all the squares around it. So let's just do this longhand really cheaply. North equals game board cell x, so north is, so I want -1, cell y -1. So there's 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8 neighbours. 1, 2, 3, 4, 5, 6, 7, 8. So it should be x -1, cell -y. So let's do this. I don't need to name them all. Oh god, I don't know what happened then. Let's do that. Return. And that probably blurred you to out of range exceptions, so okay. Try get x and, oh god, autocomplete x and y. I'll do that. Try get cell. Actually, I want a list of coords. Really, list of the x and the y's that I need to get. Because we're presuming the cell we're picking is in the middle here. Let's create a chord. Fine. Add a chord. Has an x and a y. So x -1, y -1. So I'm going to list the chords, then I'm going to try and get each one of them to deal with the outer bounds. So on x, up 1 to the left, and then up 1 on the same y, and up 1 to the right. I want on the same x, y plus, or y -1, y and y +1. I think this is right. I'll think about it once I've done it. And then x +1 so I don't got any duplication here. So given x in the middle, 1, 2, 3, 4, 5, 6, 7, 8, so I have 9, so 1 to the back and 1 down, 1 to the back and it's cell x and y, that's exactly it. There we go, so those are the neighbours. For each chord to get this in chords, if get this x, so let's make sure it's in bounds. So if get this x is lesser than 0, or get this x is greater than board get dimensions, in fact just width, so it's bigger than the width, probably bigger or equal than, continue, y with the height, otherwise we're going to say neighbours. I don't know why I keep on spelling neighbours with a T. I'm being trolled in chat as well. But it's all good. I'm allowed to be rubbish. Add board. Get this x. Get this y. Return the neighbours. And nothing blew up horrifically. So let's see what we've got in here. So there's one neighbour of the cell at 0, 0. Is that true? I don't want to loop through all of that, that's rubbish. So -1, yeah, cool. So all these things are out of bounds. In fact, instead of doing that, we could just try and do it ugly. We'll just say try. Just try that. All don't care. Let's go for that. So we get a bunch of neighbours, and then we got the rules. So if we save this and just close everything but the tests that I'm trying to get to, and I reckon I'll literally get all the rules in the last 5 minutes here. Game of Life board tests. So 2 living neighbours lives. And John, you're absolutely right, it is a bad name. But we'll get it green, then we'll refactor it. So, 2 living neighbours lives. So if neighbours count, god damn it, I'll do that. No, that's not what I wanted to do at all. Yeah. Oh, it's not rule. It's greater than 2. So cell has less than 2 living neighbours, it dies, but greater than 2, and what are the rules? Less than 3, 2 to 3 is alive, equals 2 or 3. Let's just do it longhand. Cell lives. I feel like we need some syntactic sugar here, but true. Boom, test passed, great. Two living neighbours lives, and then more than 3 living neighbours dies, so that's this one here. This one should die. That already passes, great. And now that's greater than 3, now 2 to 3 lives. Let's have one more test for that. Given 2 neighbours lives. So I think I have that test here. 1 dies, 2 lives, 3 lives. Greater than 3 dies, given more than 3 dies. Is that just the same test there? So that's more than 3. And more than 3 dies, so that's all more than 3. It's exactly the same test, given 4. I think actually I've got all the scenarios here. Which one haven't I captured? So if it's 2 or 3 it's alive. If it's less than 2 it dies. Let's just add these rules in and see if they work. Less than 2. Less than 2 or more than 3. So I'm interested as to what's going to go red when I do that. That's just not returning anything. So it's equal to 2 or 3. I think that's what I'm missing. So it's funny, the last time I did this I split out each of these game rules into actual rules that I could test independently, and I thought I'd try it differently this time, and what's actually ended up happening is I've found it a lot more difficult to test these state changes because I'm going in through the top when actually a lot of this stuff could be decomposed and tested better. But it was interesting to try a secondary approach. Okay, so that's the game of life, those are all the rules. Everything is green. Let's see if this works. So I've got my covering test here. Let's just make a random console app. Sure, console app 1. And all I'm going to do is basically copy the test into it. So Game of Life board tests, it's this here, that's the render function. And let's see what happens. Just add everything please. Great. So we've got a renderer, render board, so I equals 0, I is less than or equal to 100, let's run 100 generations, I plus plus, and let's do console write line, console clear, red sleep, I don't know, 2 seconds. So we're rendering the board repeatedly. We want to say board step. I have no idea if this is going to work, but let's see. Totally not. Interesting. So there is a bug. What is this bug? My cell is null. It appears like none of the cells are being populated, which is interesting. Why could that be? Game of Life board, 10 by 10. Let's just step through and see. Make a board, there's a generator. So now I should have some state. Rows are null. I have cells everywhere. Great. So I've got a cells, I've got a renderer. Board is going to step for each row. I'm going to step through each cell. Got a new state. But my target state isn't being updated. There's something wrong here. These should not be null. That'd be it. So if I run that again, yeah, just go through. So we're giving it a cell. Interesting in the order that those are coming out in. X, 7 and 9. Something very peculiar is happening here. And this is where I missed the pair. So, for each row, it's probably something to do with the way I'm iterating over here. Y in height, making a cell. All these tests would fail otherwise though. What a shame, I thought I was going to just hit run and it would work. 10 by 10. For each cell in rows. So that's 5, 9, 9, 9, 9, 9. That's really wrong. So I think when I'm assigning the IDs at the start, something is going amiss. X and width, X is across, height, Y is the height, X, 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 Y, Y, Y. So we've got a cell that we popped off, uninitialized, give it an X or give it a Y. This is all totally fine. So if I come all the way down to here, my board should be correctly initialized, so interesting, 0, 0 is 8, 9, 8, 9. Why on earth is that happening? This is pretty interesting actually, because I can't work it out. So how can I write a test that does this? So I've got a stack of cells that I'm passing through. Alright. Actually, I need to bring it all the way back here, so I've got my bag of cells again. Get 1, 0, 0, board 0, 0 is cell 0, 0. That's right. Ah, there we go. There we go. There we go, there we go, there we go. So is it big? I don't think that's right. But yeah, great. Everything's broken there. But it's great is this. So my cell is given an X and a Y, and then it's being put in the dimensions. So the first one is going in right, 0, 0, and the second one and that's actually the Y. As we go down the array, it should be the Y, and the X should be across. I think that's the problem. So I think if I do that, everything's going to go very, very red, but I'll find out why my tests are failing. Only 2 of them. Only 2 of them. I'm actually just going to run that console app and see if it looks like I expected it to look. And herein is the problem with testing visuals. I don't want to do all that. So I've got some state, I've got a renderer, nice step, and I'm going to presume this worked. It's interesting. Let's think. I wonder if anyone in chat can work out what I've got wrong. What have I got wrong? Is it this again? Okay, I think I'm just thrashing here. I'm not being very methodical, so let's undo those changes in the board. And let's write some assertions over the state. So, as I iterate, I'm building up row by row, but that isn't building row by row, is it? Here, Y, height, so the first row is 0, the second row, and then we've got the first row, and then we're filling in column by column to going across the width. But I think all my X's and Y's when I'm referring to the board are out of whack. I think. It might even just be this. Let's just reverse all of these and see if that magically fixes everything. Nobody's screaming at me that I'm doing the wrong thing, even though I feel like I probably am. So I'm just going to go with it. I'm not using it in many places, so X and Y, X and Y. fact that all my tests aren't failing creeps me out here. Again with my null reference exception. So my row is 10 nulls. So the obvious answer is always the correct one, which is I'm not adding my things to the collection at some point. So when I replace the board, I'm guessing I'm not actually assigning anything. That's got to be the reason. It must be the reason. Let's see. So generating the state, when I step, I get the target state. Let's put a breakpoint here. And let's watch my target state. So new, great. Target state is null, because that's all null. The step is just really subtly not working. For each cell is not null. New cell state, again, not null. So why on earth is going on here? What on earth is going on here? What is this row? This is that row for each rows. Oh. For a start, let's do that. Nothing's broken. That's good. I don't believe it. Again with the nulls. Weird. This is super weird. So right now I should expect X and Y there. So 9, 8, 9 to be populated. Let's try it out. There it is. And I come back around. 9, 9. All the way down the bottom, also populated. So this is working. Something funny's going on here. Get neighbours. Super peculiar. So there we go. There's definitely something to do with this here. So let's double check this code here. So looping through the height. Let's see what I'm actually doing here. I want a breakpoint here. I want to make sure that I'm returning the right elements, because I did this very, very hastily and I'm not convinced that it was the right thing to do in retrospect. Make a new list, and then I'm going through the width. Oh, that's why. So building the row for the current Y. This cell. Like this. Cool. So that will break. I'm honestly stumped. I've broken something really subtle. Here, trying to iterate through these cells, and I just can't see it. At all. And nobody seems to have a clue in the comments. I could cheat and look at the last time I did this correctly. Let's do that. I'm curious how this is not working here. And the last time it was very, very easy. Oh no, I don't have the code on hand. Okay, so the obvious thing to do is to rework this step, because all of the other tests are working. So given all of the other tests are working, let's do it longhand. So I'm going to copy this out. Let's do this, just comment that out. Great. Let's commit it from first principles. So going through every X and Y, existing cell equals board XY. New cell state is that. And then I'm setting target cell state X and Y to new cell state. So I think that should be equivalent to the code underneath. So everything's green again. Interestingly, worked that time. There's definitely something funky about my iterator. Cool. Okay. Great. So, haha. There we go. There we go. Right, let's destroy all of this. Yeah, I know, there's nothing like getting stuck live. It's the demo gods, isn't it? It's really, really the demo gods. It's a lot easier with a pair, put it that way. Okay, let's run through this. Let's just put this down to like 400 milliseconds. Let's see what happens. Ah, it just ran too fast. So let's step through it. I'm not going to waste a load of time making this look pretty. So board step, great. So we're going to render it. We clear the console, and we write everything. So let's get a breakpoint on every thing here. So we've got an initial state. So they're all alive, interestingly. It doesn't seem true, doesn't seem accurate. They should be about 50% alive. Let's do it on a okay, interesting. They shouldn't all be alive on the first step, should they? So let's just step into here, new cell generator. So the cell generator is the default one. And then when we generate state, generating 10 by 10, that should be 100 elements. My bag of cells. So they're all a mismatch of alive and awake and alive and awake. Cool. So the thing that I've obviously got wrong in that hacky console app is I'm not rendering the initial state. So we should render, sleep, step, render, sleep, step. I still think there's probably a bug in the step. Render. Ha, idiot. Idiot. So there's a renderer. Oh no, I did do the right thing. Just being silly. There's my initial state. And as I step, clear it, and it killed everything. So that step is definitely the root of all evil here. So I find it interesting that whatever I did before versus whatever I did now has had distinctly different effect. So I make a new target state, and that's what I was doing up here, width and height, and this is exactly the same. So here we're just allocating a cell. Here we're getting the existing cell, we're toggling its state based on the number of neighbours and the number of rules. I wonder if I've got the rules implemented in the right order. I'd have thought the rules didn't conflict with one another though. So if there's 2 alive or 3 alive, then it stays alive. If there's less than 2 alive, it dies. If there's more than 3 alive, it dies. And that's fairly tight there. I wonder, am I determining from a snapshot here? So where am I getting the neighbours from? Getting the neighbours from the board, fine. I want to step through and make sure that I'm picking out the neighbouring cells correctly. So what I will probably start doing now is breaking this out into a series of tests to make sure that getting neighbours works correctly, because this is kind of buried deep. So it definitely worked better when all this stuff was injected in the first time I did it. So I'm getting 6 and 8 because the cell I've been asked for is 7 and 9. It's a peculiar order. Six and 8. Get 6 and 8. Neighbouring cell. It seems like there's something incredibly off with the way the indexes are assigned. That's what it looks like to me. So they're kind of fine when they go in. Again, I can't help feeling like it's something to do with this here. So I presume a load of tests break if I do that. Cool. That's why, isn't it? It's something to do with this renderer. Game of Life board. So I'm going to do exactly what I did with the step method there, because that iterator is really super dodgy. I'm going to do this. Any of that. So I'm just iterating through. And that's each row. Cell equals Game of Life board XY. And let's just kill all this stuff here. Yeah, it is a shame N-Crunch is really expensive, but it's so worth it for the feedback cycle. He says, absolutely struggling to do basic loops. Something's still broken. It's probably all of the tests ever. Let's do that. Just that. Board is not null. That is equal to 30. So this is just 0, 0. Do this and just fix up these tests. I mean, they're probably all going to fail, but 0, 1, first row, second column, and 1, 1. Where else are we not building? Rows are not null. Yeah. Let's just hide that for now. I think I've got my indices the wrong way around all of these. And this is a problem whenever you're converting kind of visual layout to arrays, in that the 0 index is kind of the wrong way around. So you end up iterating through rows and then columns rather than columns and then rows, which feels a lot more natural. Seven and 8. That's because the cell. Let's walk up the call stack here. Let's walk up the call stack for my step. So actually, I think these are causing more problems than they're worth, because I think this is the source of the bugs. I don't like them, so I'm going to get rid of them. Take that out. That's going to disappear. and all this disappears, because it feels like I've got these x's and y's wrong at some point. So now we don't know where the cell is, but that's fine. Just pass in x and y. Let's change this so we don't conflict. Kind of determined to finish this now, especially because the first time I did it in an hour. I guess I must literally just be too tired today. I'm going to pass in the x and the y. You say overload, I say everything. X, Y. Let's just do that. And we got one more broken thing. X, Y. And obviously these now go away. Come on, tests. Cool. I mean, everything's still suspiciously green. So we start out with a layout, and then we step. We got a cell that's alive. No, it isn't. Okay. So that's where my state is right now. And the step. I'm going to run up to it. And there we go. So there, I believe, is the working game of life as it slowly forms a pattern. So let's bring down the sleep to like 250 and take off the breakpoints. Definitely doesn't look right at the moment though. Because normally you see them fixing into little flyer holding patterns. So I think the X and Y coordinates are still causing a certain amount of problems, but for the life of me I can't see it right now. So get neighbours. I'm not even using the cell in here anymore, interestingly. Let's remove that. So I get the neighbours of X, Y. Yeah, so all the surrounding cells. Okay, so count is alive. Okay, let's do this. So if living neighbours equals 2 or living neighbours equals 3, you're alive. If living neighbours is less than 2, move these up here. And I think those were the rules. Let me just pull up the GitHub repository to make sure. Cell has less than 2 dies greater than 3, dies. If it has 3, it lives. Okay, so it's about, I know what I got wrong, it's about the existing state. So this is, what I've missed is this is if it's already living. So, and that's the bug. If cell is alive, and that, if it's dead, if it has 3 living neighbours, it lives. Else it's still dead. Very, very longhand, but let's run that. And there we go, Conways Game of Life. All because I didn't read my own user stories and I couldn't iterate properly. So I lost half an hour of time. So let's do this with a bigger board for fun. Let's do like 40 by 30 by 30. That should probably fit in the console window. There we go. Pretty cool, hey? So that's the initial pass. What I've shown myself here is I've definitely got a gap in my test coverage, because if I go into my Game of Life board, because I misread the original spec for this check, I don't have these negative cases covered, so I'd need to cover those to make it work. Quite perturbed as to what happened with this. I feel like this should work, but definitely the assigning those X's and Y's, I think it was something to do with the fact that the type of the cells in memory, I think maybe those cell classes were being reused, so that ended up as the root of all horrible evil. But then when we pare this down, let's have a look at what we have. We have this thing that creates boards, we have this thing that steps over, and we have the switch statement here, effectively a glorified switch statement over state changes, which are the core of the rules. So let's, we can do a little bit of refactoring here. So that. Maybe one of the things we could do, let's try this out. If it is alive, and just actually take these out. Is alive there, is alive there. Break that back out into an if. That's the default case. Is not alive. And we bring that in. Don't really know if that's better or worse. Get neighbours, living neighbours count, and actually probably do that. So if it's live and it's less than 2, it's alive, and okay, so it's alive, and living neighbours is less than 2, or living neighbours is greater than 3. It's false. So that now disappears. Is it alive? And it's 2 or 3. size alive and 2 or 3 living neighbours, then it is alive. If it's not alive and there are 3 living neighbours, then it comes alive, otherwise it's dead. This all looks fine. It's a bit ugly, don't really like that. Could probably just use a tuple here. Yeah, done. So let's check naming, generate state. Let's change this to create initial state. That makes more sense. Target state. Determine cell state. Okay, let's change that to next state. So what did we learn? We learned that writing this iterator is confusing, even though it shouldn't be. We learned that we can test generated calls. So we inject a call generation strategy so that when we open up our tests, we can verify that we're generating the correct amount of objects in their initial state. We learned that testing randomness is always difficult. Testing rendering was actually much more easy than we expected. And yeah, everything else is pretty straightforward once you get your X and Y's right. I think on that note I am going to go and have some dinner. I hope you all enjoyed me fumbling through this one on my own. Thanks for watching everybody. Bye bye.